Why case statement is used? Why set is used? How do we define a function? How do we call a function? Okay, set is to replace a particular pattern. When access it based on input, we can switch, like switch in C. Then we have also seen functions. Why do we use functions? Okay, so basically for reusability, right? We see with XYZ in all occurrences, right? And is this permanent or temporary? Okay, this is temporary. How do we make permanent? This will not make change to the file. So we do set-i, and then we do substitute ABC with XYZ, then G, and this will make also changes the file and it's permanent, right? And how do we delete a particular line from a file using set? Set to D, and let us say file name. So this deletes the second line. Okay, so it's like ND, nth line will be deleted. Let us try. So I have a file. Or let us create a file. File 1, 2, 3. File 1, 1, 2, 3. And I'll just say this is file 1. So sed 1D file 1. So the first line is deleted. And what is there in file? So is it permanent or temporary? So it's basically temporary. So if we want to make permanent, let us try 1D. And now what is the file content? File content is permanently changed, right? So n is nth line. So any line will be deleted if we use with D option. Okay. So there is also another utility called awk, which set cases. Set is basically to find and replace word. Right. So set can also be used to delete the lines. From the file, right? So if you want to replace a particular word, the syntax is substitute. If you want to delete a particular word, sed and nd and the file name. So this will delete nth line from the file, right? So if you just do, you have a file. Or what is the file we created? I'll create a new file. Okay, this is the file. So I have content like this, and let us say I want to delete something. Third line, right? These are the contents. And if you do set 3d file 1, third line will be deleted. Okay, and these changes are temporary. If you want to make it permanent, you have to use -i, right? Is it clear? So basically we are deleting a line from the file, and we can make it temporary, or yes, we can do that as well. Instead of using -i, we can redirect it to a file, and we can redirect it to a temporary file, and that temporary file we can move it to the original file. So that also works. But we have in some of the distributions this won't work, so that is the option. So but in Linux most of the cases -i works, so you don't have to do that. You can use -i, which will permanently replace the contents. Okay. Basically you can create another file with deleting something. So this is the output. This output will be redirected to another file. Okay. There is a utility called awk. This is basically to extract the rows and columns. So based on the requirement. So what is the syntax? So this is named after three developers have developed this utility. Their names start with A, W, and K, and that's why it's named as awk utility. So this itself is like a programming language. There are a lot of use cases which we can use. Something like we can also add the numbers, add the columns, add the rows, and perform some arithmetic operations, and all we can do using awk. So, but basically in daily usage, to extract a column or to extract a row from a file or from a output, we can use awk. So again, we have to redirect output of one command as input to this command, and this command will process the input and it will provide the output. So the syntax is, let us say I want to extract the 9th column from LSF and LRT output. So we can do awk, and there is a syntax for that. Print $9. This is the syntax. This will extract 9th column from LSF and LRT output. Okay, so something like this. This is the reception alert output, and from this I want to extract the 9 names, right? So this column, the last column, is extracted from the entire output. So if you have a file with a lot of database transactions, and if you want to capture one column from the entire file, we can do that using AWK. So useful in case of DB operations. So as part of DB operations, we do a lot of things, right? So there, if you want to extract some column, and from there, if you want to perform something, then this command will be useful. Okay. Let us say I want to print a file and the size of the file side by side, right? So this is the output, and this is the size, and this is the file name. So how do you print? So this will print size and the file side by side. You can see the size column is also printed. The files column is also printed. Now let us say I want to separate them with something. Let us say comma as the delimiter, right? They are separated by comma. Let us say I want to separate them by tab /t. So they are separated by a tab. So we can use any delimiter to separate them, right? I want to separate by this, right? So this way we can use any delimiter to separate them, right? So basically we have a file, we have an output, and that we want to process for some requirement. One column we can extract, or one row we can extract, or we can also extract multiple rows, and also we can have an option of having a delimiter in between them, and that delimiter will be used to separate the columns. It does a lot of other things, but basically the use in day-to-day operations is extract the columns and extract the rows. Extract the columns, extract the multiple columns, and separate them. So that is basically main use, right? Or we can also do something like this: AWK and FNR is equal to print. So this will print the second row from the entire output. If you want to print, let us say the last row or ninth row. So this is the ninth row. So it will print based on the output, right? So either we can extract the row or we can extract the column. What is the $1 is equal to LSF in LRT? Saving output equal to $1. Okay. Yeah, I'll come to that. Okay. So AWK is a utility to extract a particular row or column from output. So this output can be from a command. right? We can use awk here, or this output can be from a file, and we can use awk here, right? So it may be any output. Irrespective of the output, it will basically extract and print the column or row for us, right? So uh, maybe you're performing some operation that requires a particular row from output to be captured, right? You have a file. Let me create a file. Yeah, we can say it's redirection works in any this thing, any operation you can perform redirection, right? So this is the output, right? So from here, let us say I want to extract the first column or first row, right? So how do we do that? We have to use awk, and then the syntax. So the fourth column is printed now, which is this thing, right? It has printed the fourth column from the output. If I say print $1, it will print the first column. So in some of the automations or in some of the while performing some DB related operations, database related operations, there might be a requirement to process the log files, right? So there maybe we need to extract something from a file and perform something. In that cases, extracting columns and extracting rows will be useful using awk. So we get the output from something, and then we process it and we capture a particular column or particular row using awk, right? So this can be always redirected to a file, right? If you say file, this file will have the content. So whatever is the content, output of this content, right? Is this clear? In the same way, we can also print the rows, right? So let us say same file is there, and it will print the first row. So basically what you need to understand is awk is useful when you want to extract some column or some row from a output. So it can be a file output, or it can be some command output, or it can be some application output. In case of application, there will be a lot of commands, right? So there, if you want to perform something, we can use this. Okay, is this clear? So you said you want to assign something to a variable, right? So output of one command, you want to assign it to a variable, right? So that you can do using simply say variable is equal to or inside a script. This way you can assign. Then you can process the variables using a simple for loop. So the output of ls will be assigned to a variable called var. So now var will contain the entire output of ls, right? Separated by spaces, right? So let us say I'll just set 10.sh and then echo $var. So let's change permission. So this is actually ls output. The same ls output is stored in a variable called var. So here we need to use something called backticks. So this backticks is this thing. Here there are two backticks, right? So I opened a backtick, I closed a backtick. This is basically to save the output of this command ls inside a variable, right? So this variable will contain output of this command. We have some output that we want to capture inside a variable that we can do using backticks. Okay. Is this clear? So there are some regular expressions that also we can use. It's not a single quote, it's a backtick. It's a backtick is something under escape. You can see under escape, right? So there is escape button in keyboard. Under that there is backtick. This colon or double colon or backtick, three are different. Okay, if you use just this thing single quote, it's like a string. You are defining a string, right? So if you use backtick, the output of a variable is stored inside a variable. Output of value is stored inside a variable. Okay, is this clear? So there are some regular expressions which we can use in commands that will display a proper output, the required output, something like, let us say, star. This will display, this will match 0 or more occurrences, right? If I just do lsf and lrt, it is a star release. So this will display, it will match all the content. So all the files which are ending with release will be printed, right? So the star will match all these things: OS hyphen, CentOS, Red Hat, system, etc. Right? So this is called wild character or meta character. This will, when you do LSF and LRT, it is a star release. So it basically prints. So whatever is matches, right? So here, what are the things matched? So all the files which are ending with star, ending with release are matched. So that's why it is printing all these files. So star is a meta character that matches 0 or more occurrences of release. So when release is there and it is ended with 1 release, 2 release, 3 release, or ABC release, something like that, it will match and it will print the output on the screen. Okay, so this is called, these are called wild characters or meta characters. Right. So in the similar way, we have other characters as well. So this is called caret. This matches beginning of a line. So if you want to check the things which are starting with something, let us say starting with A, starting with B, so that we can match. In the same way, the scripts ending with sh, this is for ending, right? So let us say you have a directory and you want to find out what all the files are there in the directory. I want to list out the files in this directory. So if you do lsf and lrt, grep cap or caret hyphen, so this will list all the files which are, this list all the this list of files. So basically this hyphen indicates that it's a file, right? What does D indicate? it indicates a directory, right? So inside a directory, if you want to find out what all the directories we have, you can simply say D. This will just give the directories. Here I have files and I have directories. If you want to filter out only the directories, or if you want to filter out only the files, you can do using cap or caret. So this will it will match the characters or the pattern which is starting this way or this way. So you can see in red color that is matching actually. So this is matching. This hyphen is matching. Is this clear? So the same way I want to match, let us say, uh, the files which are ending with sh. So it will list only files which are ending with sh. Okay. So star is a meta character that will match 0 or more occurrences. If you just do like this, it will list all the files. In the similar way, we have something called question mark. This will match a single character. This hyphen, let us say OS1, OS2, OS3 is there. It will print all of this because we have given question mark. This will match one character. Yeah, LSF and LRT is based on the timestamp only, right? So what do you mean by how to access the last file? Who modified? So that will be here, right? This is the user ID who modified it last time. Okay. So we have user ID, we have group ID, we have a timestamp which is modified, we have size of the file, right? So it will give all the list of things, right? So you can find out which file is modified last. Sort by size also we can do. There is, I think, something called sort-n. There is a way actually, du hyphen, there are two commands, df and du. This will display the file system size, how much is used, and one is disk used. Du hyphen k, du dot Yeah, some option is there, df-h or something that will display. I think du disk used will display based on the size with some option. Okay. Boot process I did not cover, so basically I thought it's kind of too much for the basic Linux. So I mean I can cover basically, but yeah, maybe it quickly I can cover. So it's like whenever you power on any Linux machine, the first operation which happens is post, right? So this is power on self-test, right? So what happens when you boot a machine, specifically when you boot a Linux machine, right? So there is something called post, which is power on self-test. So that is the phase which happens for the first time. This is basically to check whether all the peripheral devices, your monitor, your mouse, your keyboard is working fine or not. Now, sometimes you see when you power on a machine, you see something like keyboard is not connected, mouse is not connected. So basically it sends a signal to all the devices which are connected to the machine, and it gets the acknowledgement. If they are working fine, then it goes, and if there is some error, it will give error. And you also sometimes you see error, something like RAM is not working, or some device is not working, some disk is not connected. So those all are errors from the post stage, which is power on self-test. So this basically sends signals to all the devices which are connected to the machine, and it will so basically send. So this is like a small software which is embedded into chip that will basically sends out the signals to the hardware devices and checks whether all are working fine or not. So that is post. If post is successful, it goes to BIOS, which is basic input output system. Right. Then there are a lot of other phases which it goes through. So this BIOS is like the system settings. You can also see, you can go to boot menu and check what all are options available in BIOS menu, right? So for the first time, if you want to virtualize your hardware, we need to enable the virtualization capability. So that is actually there in BIOS, right? So you go to BIOS settings and enable the virtualization capability. By default, it's disabled. You need to enable it, then only the virtualization works. So that is basic IO, right? Then there is something called bootloader grub. I think that is the fourth option. There is something in between. Yeah, MBR. So this is the first program which gets initiated when the system boots up. So this has a very small program which is there in the RAM. So this will basically has the information like what is the hard disk, from where to boot the machine, right? And then we have bootloader, kernel, and all the processor will be started from etc init tab. So this bootloader will basically select the operating system. Something like when you open if you have a dual operating system, and when you power on, after post, after BIOS, and after masterboard record detected the disk, and then it boots it, it will show a menu, something like a flash screen, where it will give information about what is the operating system you want to select. You want to select Windows or you want to select Red Hat. That is actually the output from the bootloader. So there is a configuration file which is configured, which has information like what all the operating systems it has, and then it will give a list. right? So there we can select whether you want to select Windows or you want to select Linux. And once you have selected, let us say Linux, then the control goes to the kernel, which is like a again a software to manage the hardware, to does the process management, does the memory management, and all that stuff. Right? So once the control goes to kernel, the first process which is started is init, right? So with PID 1, the process ID of first process to be started is init, and the process ID is 1. Then it will start all other processes based on the file called etc init tab. So in etc init tab, we have a lot of information like what all the services it has to start by default. Then all the processes running on the Linux machine will be started. You can just enter reboot and see what is happening on the machine. Yes, init tab is the main configuration file. So some of the distributions, yeah, some of the distributions will have different architecture. If you take Solaris, if you take Unix, it will have different file. But basically, etc init tab is the file which is used when we boot a machine. When we reboot a machine, all the processes will go down, and then it comes up. And when the machine comes up, all these things will happen. Post will happen, BIOS will happen, MBR will load, bootloader will show the operating systems. Once it is selected, kernel will take the control and it goes to etc init tab, right? So there is also something called etc. So there is also something called run level, right? So there are different run levels available. So based on the run level we select, the machine will boot up. So default there will be a run level which is run level 5, right? So what happens is, if you want your machine to be used by only one user, there are not many users and there is only one user, and we can boot the machine in run level 1. So that is like only one user can use it, and he will be the administrator, and we cannot tell that we cannot log into the machine. There is no network, right? So there are different purposes for each run level, right? So run level 2 is multi-user without network. Run level 3 is multi-user with network. Run level 4 is not used. Run level 5 is like multi-user with network and with graphical user interface. And run level 6 is reboot. If you just say init 6, the machine reboots. So these are some of the Linux internals, right? Yeah, run level 0 is something like shutdown. You basically power off the machine. If you just go and just do init 0, the machine gets powered off. Okay, there are 6 run levels. Each has different uh, purpose. Generally, we don't use all of this. What we use is run level 5. Okay, so when we log into a machine, it has a graphical user interface, and it has network. It has multi-user capability, so multiple people can work on it, right? So these are the run levels and boot process. Yes, we can change. So basically everything is in etc init tab. If you want to change something, you can go ahead and change there. Okay. So if you want to switch to single user mode, init1. Init is the command to change the run level. Init1 will go to single user mode. Init2 will go to multi-user mode without network. Init3 will go to multi-user mode with CLI access. And init5 is for multi-user mode with graphical user interface with multi-user with network, right? So by default, what we use is run level 5. You can also check run level by giving who-r. This will give the run level of the machine. Okay. Is this clear? I'm not aware of that Windows this thing, but probably what you can do is when you reboot a machine, it will ask two things. One is go to debug mode, right? Uh, there we can log in inside the machine, and if there is any problem, and try to fix it, right? So if there is any issue with the file system and there are some blocks which are corrupted, and we want to repair it and the machine is not booting, so fsck is a command. This will do file system check, right? And it will also automatically correct some of the errors related to the blocks or the memory, right? If something is corrupted, we can run this. That will to basically repair the things. If there is any problem with the files, some files are corrupted, some memory is not proper, some blocks are not proper, all those things will be corrected using fsck. Okay. Bootloader is corrupted, we can go to the bootloader configuration file and see. But generally, I don't think we can correct it. So if there is any problem with the bootloader, most probably I think we need to reinstall the OS. We can see the you mean problem is with the flash screen, something is not displayed in the bootloader, or there are different bootloader, right? Grub and LILO. Machine is not booting up. What is the error? So that can happen because of many reasons, right? Something like a disk which is attached to the machine is not responding, or you have added a mount point and that remote machine is never responding, and it is trying to mount it and it goes in a loop. So that kind of issues this thing may come in, maybe, and we have to boot into a single user mode and then try to fix it. Okay, so it will ask when it is not able to boot or something. Is it asking to go to system maintenance mode? Press Control D to go to system maintenance mode, like that it will ask. So if you press Control D, you'll go to the single user mode where there is no network, and maybe in that case we can edit some of the files and modify the configuration and correct some of the problems, right? Is it clear? How does sed work? How does awk work? What are the regular expressions we can use? What is the meta character? When to use, etc. Yeah, yeah. So basically, let us say you want to transfer a file from Linux machine 1 to Linux machine 2. So what do? We use either a CP, right? That will transfer the file from Linux 1 to Linux 2, right? But let us say you want to transfer a very huge file, and there are a lot of contents in that file. Let us say there are 1,000 files, right? So what do we want to do? Let us say in a Windows laptop only you have two laptops, and you want to transfer files from one laptop to other laptop, right? And the file is very huge. What do? So generally we zip it, we create a tar, right? So what is a tar? We compress all the files into single file, and that single file we reduce the size and we copy it, right? So how do we do? So we simply do something like this, right? So we basically uh, tar, let us say I go to the directory /a and there are 1,000 files, tar hyphen cvf, C for compress, P for verbose, F for file. So this will create one file out of the 1,000 files. So I'll say sample.tar, and dot. Dot indicates the current directory. So this will tar means compress all the files and create a single file. Right? Then we don't, out of 1000 files, a one file is created which is sample.tar. Now this file is there, but again this is huge in size. I want to again compress it, in the sense I want to reduce the size of the file so that we can transfer it easily. So there is a command called zip or zzip. This is to reduce the size of the file, compress more, right? So gunzip and the file name sample.tar. If you give, it will create another file called sample.tar.gz. So this will be very much smaller in size, right? So there is something called gunzip-9, which will reduce the size by 40%, right? So you have a 1 GB file, it will be reduced to somewhere around 400 MB, right? So why are we doing all these things? Basically, we want to transfer a huge file. It's not a directory, it's a file. Tar is a file. We have 1000 files in a single directory. We want to compress and create a one file. Sample.tar will have 1000 files now, and it is reduced to one file. Again, that file we can zip it using zzip or zip. So the preferred one is zzip. Sorry, it's not gunzip, it's zzip. Right? Now let us say from Windows 1 laptop to you transfer to Windows 2 laptop, and it is zipped and it is compressed. Now what is the other way? We need to extract it, right? So this is on file 1 and you did SCP and the file is copied to another machine. So you logged into another machine and there is a file called sample.tar dot cz. This file is available on the machine. Now you want to extract it. So how do we do that? Unzip. So this will create sample.tar. Then when you do xvf sample.tar, this will extract all 1000 files. Right, so this is how you transfer a file. So basically, if someone asks how do you transfer a file from machine A to machine B, a set of directories, how do you transfer? First, we have to tell, like we compress, we zip it, and then we send it using a CP. Then we use gunzip to extract the tar file. Then we use tar-xvf to produce all 1000 files. In between, another thing also what we can use is we can check the checksum. CKsum is to check the checksum. What is checksum? So something like, let us say you have transferred a file over internet, and sometimes the packets may be lost, right? And it shows the size. It shows the size is proper, but actually the file is not proper, right? Maybe there are some packets which are missed, which are not properly transferred. So if we use checksum, we can find out whether file is transferred properly or not. So how do we do it? Is basically we do checksum, CKsum, and the file name on the first machine. So this will produce some output, some numbers. And when you copy and we go to the second machine, we also do same checksum and the file name. So these two numbers should match, indicating that the file is transferred properly. Okay. You mean how much size we can use for etc? That kind of restriction won't be there generally. So it is in general slash size. So out of slash, we have several directories created, right? We have slash etc, we have slash var, etc. So generally, the etc directory will be part of slash only. So if etc full slash will be full. Maybe sometimes where will be another file system. You can just check that using df-h. This will check, list out all the file systems we have. So I mean, in advanced levels, what happens is you add a disk to your machine, right, your Linux machine, and then you convert that into a particular file system, right? So one disk is allocated for one file system. So there, it's like the entire disk can be used for a single file system. Let us say you created a directory XYZ and you attached a disk and you created a file system on it. So this XYZ is completely different from slash. We can use it for filling or for log file storing or storing some binaries and all. Right? Did you get how do you transfer a file from machine 1 to machine 2? How do you use star? How to use zzip? So there is also another important utility called cut. So this will basically extract the characters to cut a file. Let us say I have a file like this. Or let us say the simple example is I want to find out whether the machine is Unix or Linux. I find out if I give uname-na, it will give the Linux and some machine name and the kernel version, hardware version, etc. Now I'm interested only this part, right? So how do I get? So there is a utility called cut-f, and so basically entire string will be cut into different parts based on the delimiter, right? This entire string is a, let us say, single string. Now I want to cut this into different pieces so that I can use first piece, second piece, third piece based on the delimiter. What is the delimiter here? Space. Right now, if I do -f1 field 1 delimiter is space, what I get is Linux. Is this clear? So we have a string and that we want to cut into different pieces, and based on the delimiter we can get whether it's a Linux machine or a Unix machine, right? So maybe you want to write a simple script that, let us say, so you want to automate something, let us say installation of package. Right. So while installing the package, we have to take care whether it's a Unix machine or Linux machine. Let us suggest, for example, Linux machine, the command is different, Unix machine is the command difference. So how do we find out whether a machine is Linux or not using Unix and uname-na output? But this is a huge output, and this has a lot of other things, but I'm only interested in this part. So how do we use, I can use this to get a particular string. Then I can simply use a if loop and extract that. Just now we have seen like how to use output of one command using the backticks, right? Then $var is equal to, this is a string, so we need to use equal to Linux. Then we can use something like execute a particular command which is related to Linux, else use something which is related to Unix. So this way it will be helpful, right? So you can execute a Linux specific commands on the Linux machine. So this script works on any machine irrespective of the distribution, right? Irrespective of the fact that it's a Linux machine or a Unix machine. You can just go and execute this command. It will take care of checking the distribution and checking whether it's a Linux machine or Unix machine specific. If you want to execute some specific commands, it will execute. Is this clear? Is this clear? Basically, we have uname-na command that will give operating system, it will give kernel version, it will give hardware architecture, it will give the host name of the machine, etc. From there, I'm only interested in one part, which is checking whether it's a Linux machine or a Unix machine. And based on that, I want to execute some command on the machine. Right? Let us say I want to get the host name from this. How do I get? We have a command to directly check host name, but if you just want to get kernel version or host name from this entire command, so this is the file. Let us say I want to extract first field. So this will give the first field. If I want to extract the second field, it will give the second field. So basically we are cutting into different pieces and using each one of them in different parts, right? So F is for field, D is for the delimiter. So delimiter can be anything, but here we are using space, right? And also we can also use this way based on the characters -c, let us say 1 to 5. So it will print the characters from 1 to 5. You can count it from here 1, 2, 3, 4, 5. So it will print 5 characters based on the characters. You can cut into different pieces and use one of the pieces based on the field number or based on the character also. You can use it. Is this clear? Okay, we'll stop here. We'll continue tomorrow. Anyone is still facing issues with Vagrant? Anyone is still facing issues with Vagrant because now we are almost done with basics of Linux. We'll be going into DevOps tools. So I want you to focus more on practice, Linux practice, and get all the commands familiar. Then we'll go ahead and start some of the tools installations and configurations and writing some scripts and all. So you should be really comfortable with all the commands which we use, all the commands which we discussed so far, right? Right. So these are the things really helpful in automation, right? You want to automate something and you want your script to be generic. It has to work on all the operating systems, right? So it's not like it only work on Linux. It will not work on Unix. So sometimes maybe your organization is using both Unix and Linux. How do you take care? So this kind of things, small things will be useful. Small checks, small if loops, right? And you capture the variable and you use the variable inside a script, right? So practice these things, the basic commands and all that stuff, sed and awk and cut, grep, all these things are used widely in the organization. So practice them. we'll continue with the DevOps tools. Okay. Any questions? Yeah, syntax is really important. So that you will get. I mean, for the first time we get a lot of errors. That's okay. We can debug with debug mode enabled. Google search for the error. You'll definitely get it. And the syntax is right, like how to use if loop, how to use while loop, how to use for loop, right? So if single space mistake also, yeah, it will throw error. We'll start with either Ansible or Git. But before that, get the basics ready, right? Be comfortable with things like commands, scripts, and all. Okay, so we'll stop here. We'll continue tomorrow. Thank you.